Magandang araw, grade 10 learners. Welcome to Math is Fun with Teacher Joy. Today, we will learn about polynomial equations. But before that, our learning competency for this week is illustrating polynomial equations. And at the end of this tutorial, you are expected to illustrate and solve polynomial equations. Let's begin the discussion. Where does the word polynomial came from? The word polynomial came from two Greek words, poly, which means many or multiple, and nomial, nominal or nomen, which means terms. So polynomial are algebraic or mathematical expressions that contains many or multiple terms. By definition, polynomial equations are equations that have multiple terms made up of numbers, variables, or a product of the two. Every polynomial equation is illustrated in this form, in which a sub n minus 1, and so on are the given constants, and a sub n must not be equal to 0. X is a variable, and n is the degree of the polynomial, and it must be a positive integer. Let's try the following illustrative examples. Identify the following polynomial equations from the given set of equations. Remember, n as a positive integer implies that n is not a negative, fractional, radical, or imaginary. Let's start with number 1. 2 minus x plus 3x squared minus 4x raised to 4 is equal to 0. A polynomial equation or not a polynomial equation? Number 1 is a polynomial equation. Number 2, 3x squared minus 4x plus 1 minus x raised to negative 1 is equal to 0. A polynomial equation or not polynomial equation? Number 2 is not a polynomial equation. Why? Because x raised to negative 1 has a negative degree or a negative exponent. Square root of 5 times x raised to 7 plus 2x cubed minus x is equal to 0. A polynomial equation or not polynomial? This is a polynomial equation. Number 4, square root of 5x plus 3 is equal to 0. A polynomial equation or not polynomial equation? Number 4 is not a polynomial equation. Why? Because the square root of 5x can be rewritten into its exponential form, which is equal to 5x raised to 1/2, in which it has a fraction exponent. Number 5, quantity 3x squared plus 2x quantity raised to 2 is equal to 0. A polynomial equation or not polynomial equation? Number 5 is a polynomial equation. Number 6, we have negative 4x squared plus 2x raised to 3 over 2 plus x is equal to 0. A polynomial equation or not a polynomial equation? Number 6 is not a polynomial equation. Why? Because of the exponent 3 over 2. Before we continue, here are the following keynotes. The degree of a polynomial is its highest exponent. It will tell us how many roots can be found on a polynomial equation. The roots, or sometimes called as solutions or zeros, of a polynomial are the values of x where y is equal to 0. Let's continue with fundamental theorem of algebra. Fundamental theorem of algebra. If p of x is a polynomial equation of degree n and with real coefficients, then it has at most n real roots. Let's try the following illustrative examples. Determine the number of roots of each polynomial equation. Number 1, x cubed plus 6x squared plus x plus 6 is equal to 0. The highest exponent is 3, which implies that the equation is of third degree. Therefore, the equation has at most 3 roots. Number 2, x plus 2 quantity raised to 4 times 3x minus 1 quantity raised to 2 times x minus 1 quantity raised to 5 is equal to 0. Applying law of exponents according to the product of powers rule, which tells us that when you are multiplying two or more terms that have the same base, you can just add their exponents. So we have 4, 2, and 5. 4 plus 2 plus 5 is 11. Therefore, the equation has at most 11 roots. Number 3, we have x times x minus 3 quantity raised to 2 times x plus 1 quantity raised to 3 times 2x plus 5 is equal to 0. According to the product of powers rule, just add their exponents. So we have 2, 3, and for 2x plus 5 we have 1, and for x we have 1. So 1 plus 2 plus 3 plus 1 is equal to 7. Therefore, the equation has at most 7 roots. Next is finding the roots of polynomial equations by applying the zero product property. If the product of two numbers a times b is equal to 0, then either a is equal to 0 or b is equal to 0 or both. Let's try the following illustrative examples. Find the roots of the following polynomial equations by applying zero product property. Number 1, we have the equation quantity x plus 3 multiplied by quantity x minus 2 multiplied by quantity x plus 1 multiplied by quantity x minus 1 is equal to 0. The equation is of fourth degree. Therefore, it has 4 roots. Now, by applying the zero product property, by setting x plus 3 is equal to 0. Add the additive inverse of 3, which is negative 3 on both sides of the equation, to have x plus 3 plus negative 3 is equal to 0 minus 3. Now proceed with the operation. 3 plus negative 3 is 0, and 0 minus 3 is negative 3. So therefore, the value of x is negative 3. Or, given the polynomial equation in its factored form, the first factor is positive. Just get the opposite sign, which is negative, to make it negative 3. Same goes with negative 2. Just get the opposite to get positive 2. Same with positive 1. The opposite is negative 1. And negative 1, the opposite is positive 1. Therefore, the roots of the given polynomial equation are negative 3, 2, negative 1, and positive 1. For the second example, we have the equation x plus 4 quantity raised to 2 multiplied by x minus 3 quantity raised to 3 is equal to 0. The equation is of fifth degree, therefore it has 5 roots. Now, applying the zero product property, the roots of the given equation are negative 4, 2 times or twice, and positive 3, 3 times or thrice. If a root occurs twice, such as negative 4, the root is called a root of multiplicity. So negative 4 is a root of multiplicity 2, which means the equation has 2 negative 4 as roots. And 3 is a root of multiplicity 3, which means that the equation has 3 positive 3 as roots. How about finding the roots of polynomial equations by applying the factor theorem? So the polynomial p of x has x minus r as a factor if and only if p of r is equal to 0. Let's have an example. Find all the zeros of x cubed plus 6x squared plus 11x plus 6 is equal to 0. In finding the roots of this kind of equation, we will use synthetic division. Remember, before proceeding with synthetic division, make sure that the given equation is arranged from highest to lowest degree of exponent. In our case, the given equation is already in its highest to lowest degree of exponent. Now, let's use synthetic division. So, let's set trial number 1 if x is equal to 1. So, if x is equal to 1, bring down all the numerical values of the given equation. For x cubed, we have 1, 6x squared is 6, 11x is 11, and copy the constant 6. Step 1, bring down 1, and multiply 1 with 1. So 1 times 1, that is 1. And add 6 and 1. 6 plus 1 is 7. 7 times 1 is 7. 11 plus 7 is 18. 18 times 1 is 18. 6 plus 18 is 24. Since the remainder for the P of R is 24, which is not equal to 0, therefore 1 is not the root of the given equation. Now for trial number 2, if x is equal to negative 1, same process. If x is equal to negative 1, bring down all the numerical coefficients of the given equation, which are 1, 6, 11, and 6. Bring down 1, and then 1 times negative 1 is negative 1. 6 minus 1 is positive 5. 5 times negative 1 is negative 5. 11 minus 5 is positive 6. And 6 times negative 1 is negative 6. And 6 minus 6 is 0. Since the remainder is 0, therefore, negative 1 is a root of the equation. To completely solve for the roots of the equation, we must convert the result we get in synthetic division into a polynomial. Remember that x cubed divided by x is equal to x squared. So the first number is the numerical coefficient of x squared. That means 1 is the numerical coefficient of x squared. Or just simply subtract 1 from each exponent. So we will now have x squared plus 5x plus 6. Now, the second trial implies that x cubed plus 6x squared plus 11x plus 6 divided by x plus 1 is equal to x squared plus 5x plus 6. Now, this is what we call the first depressed equation. Now, to complete the roots of the given equation, we must factor x squared plus 5x plus 6. The factors of the constant term 6 are 1 and 6 and 2 and 3. Since the last term is positive, therefore, we must consider the factor that when we add them, it will give us the numerical coefficient of the second term, which is 5. And this factor is 2 and 3. Thus, the factored form of x squared plus 5x plus 6 is equal to x plus 2 times x plus 3. Now, applying the zero product property, therefore, the zeros of x cubed plus 6x squared plus 11x plus 6 is equal to 0 are negative 1, negative 2, and negative 3. Lastly, we have finding the roots of polynomial equations by applying the rational root theorem. Every polynomial equation of a degree n is greater than or equal to 1 has exactly nth roots. Now, let's find the roots of 2x raised to 4 plus 9x cubed plus 11x squared minus 4 is equal to 0 using rational root theorem. So, let's begin first by identifying the degree of the polynomial. The highest degree exponent is 4, therefore, the polynomial is of 4th degree. Since it is of 4th degree, the number of roots is also 4. Now, the leading coefficient is 2. And the factors of the leading coefficient is positive and negative 2 and positive and negative 1. Now, the constant term is negative 4. Now, the factors of the constant are positive and negative 4, positive and negative 1, positive and negative 2. Remember that rational root theorem helps us easily sort out which factors of the constant are we going to use when finding the roots of a polynomial equation. Therefore, if these are the factors of the constant, according to rational root theorem, these are the possible roots of the given equation. And with that, we will proceed with the solution. Remember that the possible roots of the given polynomial is positive and negative 4, positive and negative 1, and positive and negative 2. To make it easier, let's begin with the smallest possible root, which is positive 1 and negative 1. So for our first trial, we will be using positive 1 and then negative 1. Okay, now using synthetic division, trial number 1, let's set x is equal to 1. Remember, before proceeding with synthetic division, make sure that the given equation is arranged from highest to lowest degree of exponent. If there is or there are missing terms, replace it with 0 as its numerical coefficient. In our example, the first degree term is missing, so we will use 0 as its numerical coefficient. So let's try trial number 1. If we have x is equal to 1, the numerical coefficient of 2x raised to 4 is 2, 9x cubed is 9, 11x squared is 11, and we do not have the first degree term, so we have to replace it with 0. And comes after that is the constant term, which is negative 4. Now bring down 2, proceed with the process of using synthetic division. So 2 times 1, that is 2, 9 plus 2, that is 11, 11 times 1 is 11, 11 plus 11 is 22, 22 times 1 is 22, 0 plus 22 is 22, 22 times 1 is 22, negative 4 plus 22 is 18. Since the remainder is 18 and it's not equal to 0, then 1 is not a root of the equation. Now let's set trial number 2 using negative 1. Same process. Copy the numerical coefficients again. The first degree exponent is missing, so we will replace the numerical coefficient of it by 0. And then bring down 2. 2 times negative 1 is negative 2. 9 minus 2 is 7. 7 times negative 1 is negative 7. 11 minus 7 is 4. 4 times negative 1 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 1 is positive 4. And negative 4 plus 4 is equal to 0. Since the remainder is 0, therefore negative 1 is a root of the equation. Now, to proceed with the process of finding the other roots of the given polynomial equation, we have to convert the result to get the first depressed equation. To get that easily, or to do that easily, if we have x raised to 4 as the original or the highest degree exponent, just simply subtract 1 from it, so it will be x raised to 3. So x raised to 3 or x cubed will now be the literal coefficient of the first term. So we will now have 2x cubed plus 7x squared plus 4x minus 4 is equal to 0 as our first depressed equation. So we will now use this to get the other roots of the given equation. Let's now continue the journey of finding the other roots of the given polynomial equation, but this time we will be using the first depressed equation, 2x cubed plus 7x squared plus 4x minus 4 is equal to 0, to find the other roots. Now, remember, in this equation, the constant term is negative 4. If the constant term is negative 4, get the factors of negative 4, and these are the so-called possible roots of the given equation. So, the possible roots of the given equation in which the constant term is negative 4 are positive and negative 4, positive and negative 1, positive and negative 2. Since we're done using positive and negative 1 as one of our roots, let us now try the other root, which is positive 2 and negative 2. So let's start. For trial number 1, let's set x as equal to 2. And we have this equation. So copy all the numerical coefficients of the given equation. 2x cubed is 2, 7x squared is 7, 4x is 4, negative 4 as is because it is a constant. Now bring down 2 and then proceed with the process of synthetic division. 2 times 2, that is 4. 7 plus 4 is 11. 11 times 2 is 22. 4 plus 22 is 26. 26 times 2 is 52. Negative 4 plus 52 is 48. Since the remainder is 48 and 48 is not equal to 0, then 2 is not a root of the equation. With that same process, we will now proceed with x is equal to negative 2 as our root. So, using the same equation, If x is equal to -2, copy all the numerical coefficients of the given equation, which are 2, 7, 4, and -4, and then proceed with the process of synthetic division. Bring down 2. 2 times -2 is -4. 7 minus 4 is 3. 3 times -2 is -6. 4 minus 6 is -2. -2 times -2 is +4, and -4 plus 4 is equal to 0. Since the remainder is 0, therefore -2 is a root of the equation. Now, to convert the result to get the second depressed equation, just simply subtract 1 from each exponent. If our highest degree is 3, just simply subtract 1 from it. So 3 minus 1, that is 2. Therefore, we will be using x squared as the literal coefficient of 2. We will now have 2x squared plus 3x minus 2 is equal to 0 as our second depressed equation. Since 2x squared plus 3x minus 2 is equal to 0 is already in its quadratic form, let's find the other roots by factoring 2x squared plus 3x minus 2. And since the value of a is greater than 1, we will use the AC method to get its factored form. In the expression 2x squared plus 3x minus 2, the value of a is 2, the value of b is 3, and the value of c is -2. Now, let's proceed with the AC method. Step 1, get the product of a and c, in which a is equal to +2 and c is equal to -2. 2 times -2 is equal to -4. Let's disregard the sign for the meantime. Now, list the factors of 4, which are 1 and 4 and 2 and 2. Since the last term of the equation is negative, we must consider the factor that when we subtract them, it will give us the numerical coefficient of the second term, which is equal to 3. And this factor is 1 and 4. Now, let's rewrite these factors into factored form. We have x squared has a factor of x and x. Since the last term is negative, therefore one factor is addition and the other factor is subtraction. And take note, the second term is positive. Therefore, the larger factor will be placed within the expression which has addition. Therefore, 4 will be on the positive and 1 will be on the negative. Step 2, divide each of the factors by the value of a. So that is 4 divided by a and -1 divided by a. So 4 divided by 2 is 2 and -1 is not divisible by 2. But you can arrange the expression by multiplying 2 and x to get 2x. Thus, the factored form of 2x squared plus 3x minus 2 is x plus 2 times quantity 2x minus 1. Now, applying the zero product property, the roots are -2 and +1/2. We are now almost done. So, let us arrange all the factors of the polynomial equation 2x raised to 4 plus 9x cubed plus 11x squared minus 4 is equal to 0. So, using our solution, the factored form of the polynomial equation 2x raised to 4 plus 9x cubed plus 11x squared minus 4 is equal to 0 is x plus 1 times quantity x plus 2 raised to 2 times quantity 2x minus 1. Therefore, the roots of 2x raised to 4 plus 9x cubed plus 11x squared minus 4 is equal to 0 are -1, -2 twice, and 1/2. And we're finally done. Do not forget to like, comment, share, and subscribe in our official Santa Ignacia South District channel, Math Nation. Thanks for watching. Bye!